Wow.
So this is the fifth problem what you people are asked me to solve in the board presentation. So this is what they given. So for the given circuit, find the value of the Vx. Find the value of the Vx using the nodal analysis. Nodal analysis used to the find out channel. So first of all, this is the first principal node I have selected. This is the second principal node I have selected. This is the ground node. Now what we need to do? You need to apply the KCL. You need to apply the KCL. So applying the KCL at node 1. Applying the KCL at node 1. See here, let us say, and here three branches are connected. No, I will assume this is I1. I am going to assume this is I2. Taking the pencil, mark here I1, mark here I2, and mark here I3. See here, I1 current is going away from the node. So away from the node, normally what we are going to take, we need to take is the minus 4 amps. Next, see here, remaining node here we are having, we can able to write V1 divided by 7 plus V1 minus V2 divided by 2. V1 divided by 7 is equal to V1 minus V2 divided by 2. So minus 4 is equal to, take V1 is common, 1 by 7 plus 1 by 2 minus V2 into 1 divided by 2. So if you solve this, probably you are going to get the value V1, I will segregate this term, V1 into 0.6428 minus V2 is 0.5 V2 is equal to minus 4. This is the equation number 1. Now what we are going to do, we are going to applying the KCL at node 2. So you see here at this node 2, take the eraser, erase these values. Now we are having here one branch current will be like this, another branch current will be like this, another branch current will be like this. Let us say, assume this one. So when you are applying the KCL at node 2, so I is equal to V by R now. So V2 minus V1 divided by 2 plus V2 minus V1. See here, 2 amps is coming towards the node. 2 amps is coming towards the node. So 2 is equal to next 2 is equal to V2 minus V1 divided by 2. So here positive voltage undi. Already we have assumed this positive. Always the principal node will be positive nodes only. So when both the voltages are containing the same polarity, you need to be subtract. So V2 plus V2 minus 50 divided by 5. V2 minus 50 divided by 5 is equal to 2. V2 minus 50 divided by 5. So now take V2 will be common, 1 by 2 plus 1 by 5 minus V1 into 1 by 2, okay, minus 50 by 5. Minus 50 by 5 is equal to 2. So V2, 1 by 2 will be 0.5, 1 by 5 will be 0.2. So 0.7 minus 0.5 V1 is equal to 2 plus, this will be 5 tens are no, 2 plus 10. So while writing the equation, 0.5 into V1, 0.7 into V2 is equal to 2. This is equation number 2. So solving equation 1 and 2, probably you are going to get solving equation 1 and 2, you are going to get the value of V1 and V2 will be, V1 value 16 volts and V2 value 28.57. Aim find out cheymananu. What he said to find out in the problem? He said to find out the problem in Vx. You need to be calculated the value of Vx. So where is the value of Vx? Vx is located between the two nodes. That is where V1 minus V0. So what is the value of V1? 16 volts minus 0. So you are going to get Vx is equal to 16 volts. Like this, you need to solve the problem. You have asked to solve one more problem. This problem, that is question number 7. Question number 7. So using nodal analysis, find the value of the current. In the given circuit. What is the circuit? He is given the circuit is like this. This is 2 amps. This is 2 ohm. Here we are having one 2 ohm resistance. Here we are having one 2 ohm resistance. Then you are having one 4 ohm resistance, 4 ohm. Here we are having 6 amps. Here we are having 6 amps. Then you are having here 4 amps. This is 4 amps. This is the circuit is given. You are supposed to find out what is the value of the current. This is 2 ohm. So what is the value of the current? This is what he said to find out. Okay. So first of all, what we need to do, you need to be identified. This is 2 amps. Okay. You need to be identified how many principal nodes are there in the given circuit. Let us say where I am going to select, this is the one principal because more number of 3 branches are connected to the particular point. So this will be identified marked as V1. This will be marked as V2. This will be marked as V2. Okay. So now see here, at this particular point, 2 amps is coming towards the node and 4 amps is coming towards the node. What I said, whenever the total current flowing towards the junction is equal to the total current flowing away from the junction. So towards the how many currents are coming, so that many currents. So applying KCL at node 1. So 2 current sources are coming towards the node, so we are going to take as a positive is equal to, next another branch will be like this. Let us say this is I1 and let us say this branch will be I2. So this how we are going to write the equation, for this current. So V1 divided by 2 plus how we are going to write the equation for this branch, V1 minus V2 divided by 2. That's all. So 2 plus 4 will be 6. So take the V1 will be common here, 1 by 2 plus 1 by 2 minus V2 into 1 by 2. So 1 by 2 half plus half will be 1 minus 0.5 into V2 is equal to 6. So if you write the equation like this, then it is easy while entering by using the calculator. Now applying the KCL at node 2. We are going to apply the KCL at node 2. Take the eraser, erase this value. You need to be calculate I, erase these values, leave it. Now applying the KCL at node 2. Applying the KCL at node 2. See here where 4 amps is going away and 6 amps is coming towards the node. Okay, so 6 amps is coming towards the node is positive, 4 amps is leaving the node is negative. Next remaining current will be this current and another one will be this current. Okay, another one will be this current. So how to write the equation? V2 divided by 4 plus V2 minus V1 divided by 2. V2 minus V1 divided by 2. So 6 minus 4 will be 2. Take V2 here, 1 by 4 plus 1 divided by 2 minus V1 into 0.5. 1 by 2 will be 0.5. So 1 by 4 0.25. 1 by 2 is 0.5. So you are going to get 0.75 V2 minus 0.5 V1 is equal to 2. So how to write the, you can still write the equation like this. Properly. Minus 0.5 times of V1 plus 0.75 V2, 0.75 V2 is equal to 2. This is equation number 2. So solving equation 1 and 2, you are going to get the value. V1 is equal to 11 volts. V2 is equal to 10 volts. Now he said to find out the current in 5 ohm. This branch, E branch lo current ఎంత ఉంది, how much current is there in this branch. This is what important. So I is equal to what? V divided by R. So this 2 ohm branch is connected between the node 1 and node 2, V1 and V2. Therefore I is equal to V1 minus V2. Take care, V1 is higher than the V2. So I have written V1 minus V2 divided by R2 ohm. So 11 minus 10 divided by 2, that is 1 divided by 2 will be 0.5 amps. This is what the solution for the problem. Thank you for watching this video.